Investigation of Curves, Section 2, Derivatives of Curves. Video 5, Equations of Tangents, Chords and Normals to Curves with Polar Equations. We've already looked at how to find the gradient of this particular example. So this is r equals sine 2 theta plus 1. We worked out the derivative of this in a previous video. Now we've been invited to find the coordinates of the points where the curve is at a maximum distance from the origin and to show that the normal to the curve at these points passes through the origin. So let's have a look for the coordinates of the point where the curve is at a maximum distance from the origin. Well, looking at the graph, it looks as if it's somewhere here and somewhere here. But let's see what we can work out. One way of doing this is to consider the graph y equals sine of 2x plus 1. So instead of r and theta, thinking about what this would look like with y against x. And I can sketch this out. There's the line at y equals 1. And this is just y equals sine 2x shifted up by 1. So it's going to start there and go up and down like that by the time I get to 2 pi. So this is at a maximum. It reaches the height of y equals 2 at pi by 4 and then here at 5 pi by 4. So that's telling me that r equals sine 2 theta plus 1 is going to reach a maximum distance from the origin of 2 at the point where theta equals pi by 4 and theta equals 5 pi by 4. Now this is a time that when you might think about dr by d theta, because what we've just done here is equivalent to solving dr by d theta equals 0. We want to know the maximum value that r takes and the value of theta where that occurs. Okay, so what have we got then? We've got that when r equals 2, theta is pi by 4, and the other time when r equals 2 is when theta equals 5 pi by 4, and this is the maximum distance from the origin, and in Cartesian coordinates that's going to be x is root 2 and y is root 2, and this one is going to be when x is minus root 2 and y is minus root 2. Now for the second part of the question, we've been asked to show that the normal to the curve at these 2 points passes through the origin. So we're going to need to work out the gradient of the normal. Well, here's the expression for the derivative that we worked out in a previous video. What I want to know then is I want to know the value of this derivative when theta equals pi by 4. So I want to substitute into the expression which is in number 5, and I want to substitute in the value theta equals pi over 4. And that's told me that the value of the gradient at that point is -1. And I can also substitute into equation 5 the value theta equals 5 times pi divided by 4, and that's also given me -1, which is what I would expect looking at the graph, because the gradient here and the gradient here looks as though they're parallel. So now that I know everything that I need to do to finish the question off, I know that I'm considering the point where x equals root 2 and y equals root 2. I know that the tangent has gradient -1 because my computer algebra system just told me that. And that means that I know that the normal has gradient of -1 over -1, which is just 1. And then I can use y minus y1 equals mx minus x1, so y minus root 2 equals 1 times x minus root 2, but that just simplifies to y equals x, which passes through 0, 0 as required. And I can do exactly the same argument for negative 2, negative 2, and show that I get the same line. In this video, you've seen an example of how to solve a problem about a normal with curves expressed in polar form.